Welcome back, students. Today it is the last session. In this session, we'll be discussing about the topics electric flux, electric dipole, and electric dipole moment. Electric flux. Just refer to the figure. You can see one area which is given by a red shade, and through that area flux lines are passing through, which are the electric flux lines, which are indicated in green color. The number of field lines crossing per unit area is termed as electric flux, and electric flux is a measure of the strength of the electric field at that point. That means if more number of flux lines are passing through a given area, we say the strength of electric field is more in that area. For getting an equation for electric flux, which is denoted by phi, just refer to the figure given in your slide. You can see one area given by a blue shade, and you can see the direction of electric field lines passing through that area. Area must be treated as a vector whose direction is always perpendicular to its surface. So you can see the direction of area being marked by A, which is a vector. And A and E make an angle of theta with each other. The direction of A is always perpendicular to the surface. And according to the equation for flux, phi is equivalent to EA cos theta, or in terms of dot product, you can say it to be E dot A. Or if you are taking a small area ds into consideration, electric flux phi is defined as E dot ds, and it is a scalar quantity. Suppose if the area doesn't have a regular shape, then also we can calculate the electric flux. The direction of electric field is given in your figure, and you are considering a small area over the irregular surface. The direction of area is always perpendicular to the surface, and let the small segment of area taken by you be dA. Then according to the equation for flux, phi is to be taken for this area as E into dA into cos theta. Suppose if you want to calculate the total flux through the entire surface, then you have to integrate this expression. That is integral of E into cos theta into dA. The total integral will give you the total flux through this irregular surface. Next is a very important topic about electric dipole. Just refer to the figure given below. You can see a plus q charge and minus q charge separated by a distance of 2a. An electric dipole is defined to be a pair of equal and opposite point charges plus q and minus q separated by a distance of 2a. Point charge means the size of the charge will be very small compared to the distance between them. The following points may be noted about an electric dipole. The direction of the dipole is to be taken from minus q to plus q. The midpoint of minus q and plus q is called the center of the dipole. The line joining minus q and plus q is called the axis of the dipole. The total charge of the dipole is 0, but the total electric field of the dipole is not 0. Coming to electric dipole moment. The electric dipole moment is defined as the product of charge q of the dipole and their separation distance 2a. Dipole moment is represented by the symbol small letter p. P is equivalent to q into 2a into unit vector p. Since charge and distance are scalar quantities, in order to make the right hand side a vector quantity, you are multiplying it with a unit vector p. The direction of dipole moment p is always from minus q charge to the plus q charge. And as we are aware, dipole moment is a vector quantity. Coming to the SI unit of dipole moment, the SI unit of charge is coulomb and the SI unit of distance is meter. So the SI unit of dipole moment, electric dipole moment is coulomb meter, which is abbreviated as capital C and small m. Hope you have understood today's session very well. If you have got any doubts, you can clarify it. And please be prepared with this topic for the next class. And your class assignment will reach you shortly. Take care, stay home, stay safe. Thank you, my dear children.